Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And we talked about how the overloading and overriding of the native methods is possible in Java. And we said that we can overload a native method with another native method or with non-native regular methods. And then we said that overriding also is possible. If we have a native method in one superclass, we can override it with a native or a regular non-native method in a subclass. And then we said that when we override a native method with another native method in the same class, what happens here is that JNI has to ensure that the name of the functions that are generated in the C++ are unique. In order to do that, we know that the signature of the native methods in Java are the same. The signatures are the same. The only difference is the signature of the parameters that go into those methods. So JNI adds the signature of the methods to the functions that are generated in C++. And we said that there are typically three cases. Case one is when we are overloading a native method with another native method in the same class, and we know that if the two methods are in the same class, their signature in the C++ is Java underscore package name underscore class name underscore method name. So package name, class name, and method name are basically the same for these two methods. So the package name here is test.overloading. The class name is overload native. So if you look at what JNI creates for the header files, we have Java underscore test underscore overloading underscore overload native or underscore function, which is exactly the same for both cases, for both native methods. So the way that JNI differentiate these two methods and gives them unique signature in C++ is by adding an underscore underscore and then the method parameter signature. And we said that for this function, the method parameter signature is D, a double. It takes a double. So we have underscore underscore D. And for the other function, it takes two double parameters. So the method parameter signature is DD. So the function signature is underscore underscore DD. All right. So this is one case. And we said that if in the other case, if there is a native method that we are overloading with a non-native method. So we have one native method and we overload it with a non-native method. And note that non-native methods must have a body or implementation because I'm assuming here this method is not abstract. It can be abstract and then we have to override it in a subclass. But here I'm assuming I have a native method and then a non-native or regular method that implements the function, has some implementation. Note that if this function, even though it's non-native, it cannot only have one parameter, double x, because that's not a valid overloading. A valid overloading of a function or method means the signature is the same, so the return time is the same, the name of the function is the same. The only difference is the number of parameters or the type of parameters, okay? And if you see what happens here, JNI only creates a header for this native method, but it doesn't add the method's parameter signature because there are no other native methods in this class that are overloading this particular native method. We only have one native method, so just the regular identifier Java underscore package name underscore class name underscore method name is enough to uniquely identify this method function. All right, that's why we don't have underscore underscore D anymore, because there is no other native method that overloads this particular native method. All right, so when we overloading native with non-native method, I'm assuming here we only have one native method and we are overloading it with a bunch of other non-native methods. So I'm assuming that we only have one native method. Then there is no need to add method parameter signature, okay? So another case is, we said that typically the valid overloading is when the signature of the method is the same, i.e. the return type is the same, the name of the function is the same, only the parameter type is different, or the number of parameters. But there is another case. Let's say this native method is returning a double. It takes a double value and returns a double. So its signature is DD. D is the parameter, the other D is the return type. All right. But now assume I have another function which is native. So this method is exactly the same. It takes a double array and returns a double array. Now this is allowed in Java, right? If we do something like double X, so both methods have the same name, take the same parameter, Java doesn't allow this. So this is a compiler error because method binding happens at the compile time. So at the compile time, the compiler needs to know which function to call when the user writes a code. And these two, because the compiler doesn't look at the return type. The compiler says, okay, there is a method called func. It takes a double parameter, and now I see two of them, and I don't know which one to call. So it's a compile error. So it's not a valid overloading. So if I do double, so if I change the type of parameter, now the compiler allows you. Because again, compiler doesn't look at the return type. It looks at the function, and then looks at the type of parameters that go into this function, this method, right? And at the compile time, compiler can always uniquely identify these two because it looks at the type of parameters, and the type of parameters inside this function, inside this method, is known to the compiler at compile time. All right. So we have these as native methods, and it's more or less a valid overloading. And then so it has to abide by the overloading rule that the JNI follows. So Java underscore package name underscore class name underscore method name is not enough to distinguish these two. So we have to also add the method parameter signature. So for the first one, the parameter signature is D, and it returns a D. For the second one, the parameter signature is a double array, and arrays are identified by a square bracket, an open square bracket, and D. All right. So maybe if I zoom in, you see this array is a square bracket D. So this means a double array. So if I want to have an int array, it's a square bracket I, for example. And then it returns also a double array. So the return type is also a double array, right? So these two are valid overloading. And again, as you can see, JNI adds this extra method parameter signature to distinguish the signature of these two functions in C++. So from Java underscore all the way to the function name, the signature is exactly the same. So what changes is the method parameter signature. And for the first one is underscore underscore D. The second one is underscore underscore 3D. Underscore 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 3D. Now what happens here is that in C++ it doesn't allow you to add a square bracket to the name of a function. So instead what Java does is adds the underscore 3D. Underscore 3D means it's a double array. Okay. And we've seen this with like the string. So if it's an object, then we know that the signature of objects is L, the object signature, and semicolon. And we said that we cannot have semicolon here, so it used underscore 2. So underscore 2 is semicolon, underscore 3 is this square bracket. So these are the codes that you can find by googling the Java native interface JNI and its conventions. So underscore 3 means a square bracket, therefore underscore 3D means a square bracket D, which means a double array. Underscore 2 means a semicolon in the name, right? Alright, so in general these are the three main cases. One is overloading a native method with another native method, only the method parameter signature is different. The other one is overloading a native method with a non-native regular method, which should have a body, and in this case we don't really, JNI doesn't add the method parameter signature because there is no need for that. And then finally we can overload a function with a method with another method. The signature type is different, but the return type is also different, right? As long as the signature of the parameters is different, the return type can be the same or different. And we said that here JNI still has to add this underscore method parameter signature because this is an overloading of a native method by another native method. And we said that a square bracket means an array, and it translates into _3 for the signature of the method. Now let's head to Eclipse and try to have a look at these cases. So let's create another package here. Let's call it test2. All right, and here I'm going to create a class. Actually, let's go to the Java perspective, and I'm going to create a Java class. Let's say overload1, right? And here what I'm going to do, here I'm going to say public native double func double x, and then public native double func double x double y. All right, and basically I'm overloading a method that has the same signature return type with another method that has different parameter type, and I'm putting my header files in this header folder. So if I look at my Java H configuration, it puts them in the workspace :native project, native C, which is my C++ project, and then puts them in the header folder. All right, so I've already configured my Java H to create the header file for a Java file and puts it in the header folder of the C project. This is one of the beauties of mixed development in Eclipse IDE. So if I select this and run my Java H tool, I will see the header file here. And again, the convention is that we have the package name underscore class name. So package is test2, class name is overload1. And let's look what happens. So I am doing overloading. So the signature is the same, Java underscore package underscore class underscore method name. But then we are doing overloading, so we have to add the method parameter signature to the function signature underscore d, and here underscore dd. Okay, now if I remove this native and let's add a body return x. So what happens here is that we have only one native method, so the JNI doesn't need to differentiate these this native with another native overload. So this is a non-native overload. So as you can see here, underscore d is gone because there is no ambiguity in this naming for this function, right? Java underscore package name underscore class name underscore method name, it's enough to uniquely identify this function or this method. And the last type here is that public native double array func double x, and we said that this is not a valid overload because compiler doesn't care about the return type. The return type basically happens, compiler looks at the method name, the name of the method, and the method parameter signature, and these two are basically identical to the compiler when the compiler does method binding. So it returns an error. It gives us an error, says that the duplicate method. All right, so we can say, for example, change the return type to double array. So if I run the Java H, and you see that now what happens here is that again JNI considers this as overloading because we are in fact overloading, even though the return type is different, the name of the function is the same, and the parameter signature is different. So we expect to see this double underscore this double underscore d underscore, and then we said that this one, the method signature, the parameter signature is d, so underscore d, and this one takes a double array, and we said that a square bracket translates into _3, and we said that a semicolon translates into maybe let's write it. A semicolon translates into _2, for example. So here underscore is the convention, and then instead of having a square bracket d, we have _3d. So if I do underscore D, as you can see, the C++ doesn't allow this to happen, syntax error. So we have to, instead of square bracket, we have to use something else. And JNI uses underscore 3. So underscore 2 is for semicolon, underscore 3 is for a square bracket, which basically appears for the arrays, double array, int array, all right? So for example, if I, instead of having this, if I have a float array, again, this is a valid overloading, float, because the type is different. So if I run the JavaH again, as you can see, now we have 3f. F is float, and again, underscore 3 is for the square bracket. And then the return type is an array of double. So it's a J double array. We will look at how to handle double arrays, or basically arrays, primitive type arrays in C++ and in JNI. So we will look at this in future lectures. So as you can see here, we have underscore 3D, which means underscore 3 is just a square bracket, and a square bracket D means it's a primitive type array of doubles, so it's a double array. Underscore 3 is a square bracket, underscore 3f, it's a square bracket f, which means it's a float array, all right? And if I, for example, have another one that returns the float, again, this is not a valid overloading, so the compiler doesn't allow us to do this. So I comment this one out. So I'm taking a float array and returning a float array. So if I run the JavaH on this to generate the header file, now we have a JFloat array as a return type. Here we had a JDouble array, here we have a JFloat array. And again, return type doesn't matter. The signature of the method or the function is independent of the return type. It's just the name plus the signature of the parameters. That's why Java adds these for the overloading. Okay, so now let's look at another case. Let's say public native double array, for example, or just double func double array of x. All right. So obviously this is not a valid overloading with this one because the return type doesn't matter. But let's add another object. So let a string text. So this is a valid overloading, and let's also remove this float one. So these are all valid overloading, right? And let's see what happens in the JavaH. So what do we expect to see here? For the first one is underscore D, because the parameter type is D. Here is underscore, it's a double array, right? But we cannot have this square bracket, so this square bracket translates into basically underscore 3, underscore 3D, okay? What about here? And here we have a underscore basically double array. So double array, and then a string. A string, if you recall, translates into something, it's not easy to remember, but as I mentioned, in the Java perspective, we have this bytecode. So if I click on this, it tells me the signature completely. So if I zoom in, you see that basically the bytecode is very helpful, and I highly recommend it when you're doing mixed development with C++. Definitely have this bytecode on your view somewhere so that you can quickly see the signature of the methods, the type of parameters, or the signature of parameters. So square bracket D, so let me just copy this. So this translates into something like this, a square bracket D, which means it takes a double array, and L Java /lang/ string semicolon. This means a string object, all right? But there are two things here. So we cannot use this in the method signature because the C++ compiler doesn't allow this. And we said that a square bracket translates into underscore 3. So we end up with underscore 3D. And then we have the L Java /lang/ string. But semicolon, we're not allowed to use it. So basically, semicolon translates into underscore 2. All right. So again, square bracket translates into _3, and semicolon translates into _2. So if we create a Java H now, let's see what we get. All right. So this is our func, right? This is our function. Takes a double parameter. So __d, as we mentioned, __d gets added to the Java underscore package name underscore class name underscore method name, and then the second one takes a double array. So a square bracket d and a square bracket, it translates into _3. So __3d. All right. And then finally a square bracket d l java /lang /string semicolon. So we start with a square bracket d, and a square bracket translates into _3. So _3d means the first parameter is a double array, and then l java underscore, actually the slash, we cannot also have a slash, right? So a slash also translates into underscore. So the method signature is java underscore lang underscore string. So we cannot have a slash in the name. So if I have, for example, a slash, I get a syntax error in the C++. So _3 means a square bracket. So _3d means a square bracket d, or basically a double array. A slash becomes underscore, and then l java underscore lang underscore string, and we cannot have semicolon, so the semicolon becomes _2. So this is how we write the valid basically JNI method or JNI function that corresponds to an overloaded function or method in Java, which has a double array and a string object text. All right. And again, definitely use this bytecode as much as you can, because basically that helps you a lot in quickly finding the signature of the methods and parameters. So if I click somewhere in this class file, it shows me the bytecode for the entire class. And if I zoom in, basically you see everything there. So this class, the signature is package / class name. Okay. And then we have 3 methods. One takes a double and returns a double. The other one takes a double array and returns a double array. The other one takes a double array, square bracket d, and l java /lang /string semicolon. This is the signature of an object. Whenever we have something that starts with l and ends with semicolon, it's the basically the signature of a basically object. So it takes a string object, and we said that how this translates into the function signature in C++. So a slash becomes underscore, semicolon becomes _2, and a square bracket becomes _3. So if you don't want to use the JNI tool or Java H tool or Java C-H tool, and you want to write the header file yourself, you have to be aware of these conventions. Okay. But again, it's extremely easy to set up everything, set up these external tools in basically the Eclipse IDE. And if you don't know how to do it, definitely check out my previous lectures on how to use the Java H for Java JDK 8 or Java C-H for JDK 9, 10, 11 or above. And once you have that, creating the header files, it's no brainer. You just select your Java file, run the external tool, and bam, you get the header file. So you don't need to really worry about how to generate the header file. All right. But in case that you really want to write your own header file from scratch, you have to be aware of these conventions. What happens to array? We cannot have square brackets in the method in the function name in a C++ code, so we have to substitute the square bracket with something else, and it gets substituted by _3, semicolon by _2, and a slash also becomes underscore. All right. Now let's see. As I mentioned, if you look at the bytecode here, the signature of this class is package name / class name, right? Test / basically this is test / overload 1, right? But let's say I have a method public native public native void. Let's say it's void, and then we have a func that takes a class. This takes this class, overload one like object, right? So again, this is still a valid overload because the method has the same name, but the type of parameters is different. So method parameter signature is different, and compiler allows us. So what happens here? So this is again an overload. So JNI has to add this underscore method signature, method parameter signature. So what will become the method parameter signature here? It's underscore the object, right? How do we write the object? Object is L. It starts with L and ends with semicolon, and then we add the package / class, right? Package hierarchy, which is test / class, which is overload one. So this is the initial one, but then we cannot use this because C++ doesn't allow us to have a / or semicolon. So underscore L, / becomes underscore, overload one, semicolon becomes underscore two. All right, again, this I'm repeating this for you to really understand how this translation happens. So if I run the Java Edge tool, and it's taking some time to build. All right, so if you look at here, so this is our D underscore D underscore 3D underscore 3D, which is Java array, L Java underscore lang underscore string, semicolon is underscore 2, and here we had underscore L test2 / overload 1 semicolon. So we end up with L, so underscore L test2 underscore overload 1 underscore 2. So underscore 2 means semicolon. All right, underscore L test, this was actually test2, the package name, underscore overload 1 class name underscore 2, which means semicolon. All right, so I hope you understand this. So what happens if we have two object, overload 1 object 2? So if we have two object, then what do we expect? We expect underscore L test2 / overload 1 semicolon, L test2 / overload 1 semicolon. All right, so this is the signature we expect, which means L semicolon is one object, L semicolon is another object. We have two objects of type overload 1, but this is not valid, so this gets translated into underscore L test2 underscore, so / becomes underscore, overload 1 underscore 2, L test2 underscore overload 1 underscore 2, semicolon becomes underscore 2. So let's double check this. So we run this, we go here, the last one. So what happens? So we get this signature. Let's copy and paste it and compare it. So Java underscore package name underscore class name underscore method name is the original one, the one we expect, and then we get underscore L test2 underscore overload 1 underscore 2, and again underscore 2 is the semicolon, and then the other object L test2 underscore overload 1 underscore 2. All right, so semicolon gets replaced by underscore 2 because we cannot have semicolon in a function name in C++, and then / becomes underscore because we cannot have / in the function name in C++, and then yes, so underscore is there because it indicates a overloading of the methods. So underscore means overload. So when you see a header file for JNI, if you look at someone else's project, and you see that there is this header file that has a function that has the underscore, it means it's overloading another method in Java. So this is an overloaded function. And then now with this knowledge of how this underscore what this means, and then the other things, what are the other underscores, what is underscore 2 underscore 3, now you can really understand when you look at this. Okay, this is a method in package test2 for a class object 1 or overload 1 the method name is function, and then it's an overloaded method, and its parameter type is array, double array, because it's a square bracket or underscore 3D. Now obviously you can look at the signature also, but maybe you're looking at someone else's code and they didn't add these comments, so you end up with something like this and you want to make sense of it. So you already know the return type, J double array is just a double array, and then it starts with Java underscore. So this is, you can obviously see that this is a JNI function, so this is JNI binding from C++ to Java. And then it's in a test2 package. The class name is overload1, and then the method name is function. Underscore means it's an overloaded method, and underscore 3D means it's a square bracket D, or the parameter name, the parameter type is a double array, as we see in the signature. For example, this one is the very complicated one. So underscore means it's an overloaded method. And then L test2 underscore overload1 underscore 2. So underscore 2 means semicolon. So L semicolon means it's a object. It's a non-primitive type. So L semicolon. So what is this object? It's in the test2 package, and the name of the object or class is overload1. And we have another L all the way to underscore 2. Underscore 2 is semicolon. So L semicolon means it's a class or an object. So it's in the package test2, and the name of the class is overload1. Obviously you can also see that from this signature. All right, but again, this information is most useful when you try to write the header file yourself. So you have this, it's a very complicated things in general to write this header file for this type of overloading of methods. So I don't recommend you just write that yourself. It's best to have this Java H or Java C-H and generate the header file automatically. That's the best approach. That's the least error prone approach that you can take. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.